Hey, Latte, how are you? I'm fine, thank you. Why do you want to meet me? Oh, I want to ask you about our last lesson about using electron beam in food preservation. Oh, if that's the case, I think Junha can explain it better to us. So let's go find him. Let's go. Hi, Junha. Hi. Are you busy? No, what? I want to you to explain to us about preserving food by using electron beam. Oh, sure.
Electron beams are streams of electrons observing discharge tubes. It is the method that high energy electrons to treat and disinfect food products. E-beam is a non-thermal method of food processing. It is said so because during the process, there's no heat transfer between the machine and the food product. An electron beam is not radiation because it is an electron accelerated through an electric current, but it can be used for irradiation because it has a lot of energy. The electron beam was observed in 1859 by German physicists Julius Electron and Johann Wilhelm Hitler. They discovered a new phenomenon while doing their research and named it cathode rays. And in 1897, British physicist J.J. Thomson found out through an experiment that it was caused by an electron. And I called someone to explain about mechanism. Hello. Can you come here?
Hello, Junha. Yes? Oh, do you want to know more about the mechanism on how e-beam machine works? Okay, let me explain you. We'll make video call, okay? So, I will explain to you with two parts. First, the mechanism of the machine itself. And the second one is the mechanism on how the e-beam will preserve food. For the machine itself, e-beam irradiation technology generates high-energy electrons using compact equipment called linear acceleration. Firstly, low voltage power is applied to the tungsten filament in the electron gun to boil off electrons. Then, the excited electrons will align into a half-inch diameter beam. Next, the electron's acceleration will be increased to 99.99% speed of light using a high voltage feed and pass through a vacuum tube. The installation of the scanning electromagnet is to manage the size and orient the electron beam in a specific way. Scan horn is used to create a vertical curtain of accelerated electrons. It is important to add this feature to increase the accuracy of which the ray will be going. So now let's talk about the mechanism on how the accelerated electron can preserve food. As accelerated electrons pass through food, direct and indirect ionization effects will occur. Direct ionization effect is a term used when electrons from the electron beam interact with molecules within food. This reaction leads to ionization, which causes the double-strand DNA to break. Thus, it will inactivate the organisms and pathogens. On the other hand, indirect ionization effect is when an electron beam causes splitting of water molecules, which generate highly reactive free radicals like hydrogen peroxide, hydrated electrons, and protons. This free radical also causes the breakage of DNA double strands. As we can see, electron beams terminate microorganisms and pathogens which reduce the initial microbial count, and that is how the electron beam helps in preserving food. But you must keep in mind that every mechanism has its own advantages and disadvantages. To understand it more, I suggest you to find Alif and go ask him. Till we meet again,
Hello there. Today, let's dive into a fascinating world of enhanced food safety through electron beam sterilization. Picture this: food that is free from chemical residue, doesn't involve radioactive elements, and leaves behind zero nuclear waste. I will talk disadvantages with ways to preserve food in two parts, where the first one is advantages to the food, and the other part is the advantages from the point of view of the process. Moving on to my first point is it enhances food safety. Electron beam sterilizations ensure a clean state of your product. No residue, no radioactive elements, and absolutely zero nuclear waste. We're talking about demonstrate sterility as assurance level, giving you product ready to immediate use without ever fault. Using extra tests. My second point is extending the shelf life. But wait, there is more. Beyond the just eliminating food pathogens, electron beams, irradiation extend the shelf life of your favorite food items. How? Of course, by taking out those inactive organisms in your foods. Moving on to my other part, my second part, that the point view from the process is the production rates. Now let's talk about speeds. With today's high energy electron beams accelerator, our sterilization process is a lightning fast. We're talking about processing a whole truckload of your product in just a matter of hours. And the bonus, it's often gentler on materials compared to other irradiation techniques. And my last point is, of course, when we're using electron beam or accelerated electron, it's environmentally friendly. Let's talk about green. Electron beam irradiation is an eco warrior. No residue, no byproduct, and just clean food. Say goodbye to excessive packaging and chemical additive. It's a win sustainable food preservation practice, resulting in a smaller carbon footprint. That's all part advantages from me, and moving on to the disadvantages, I will give it to Iman.
Alex already explained about advantage of food irradiation. So here I will explain about the disadvantage of food irradiation. There is 5 disadvantages of food irradiation: vitamin content, cost efficiency, effects on food hygiene, lack of choice, and consumer perception. For the vitamin content, the process of irradiation can leave macronutrients like protein, fats, carbohydrates, and minerals unaffected. But it is not the same for vitamin content. For the cost efficiency, establishing and maintaining facilities for food irradiation can be expensive. The cost of the equipment and the operational expenses may be a disadvantage for smaller food producers. For the effects on food hygiene, there are concerns that the expensive use of this method of food preservation may result in less stringent food hygiene and handling practices. Irradiation is not a substitute for good hygiene practices. For the lack of choice, consumers who are still skeptical of such practice want to be able to choose between food that has been irradiated and those that have not. Authorities have made sure this happens through mandatory labeling. And last, for consumer perception, there may be hesitancy among consumers to accept irradiated food, even with scientific evidence supporting their safety. Public perception plays a significant role in widespread adoption of this preservation method. So we already explained about intro, mechanism, advantage and disadvantage. So I will hand to Rushadi to explain about application in food.
Last but not least, I will explain how electron beam applied in foods. So there are 4 parts of application in foods, which is, for the first one is seafood products, second meat and poultry, third biodegradable packaging, and third one is package sterilization. So for the first one is seafood products. Electron beam irradiation process actually has been applied in the seafood industry. Electron beam can be used to carry out pasteurization, sterilization of the product without changing the sensitive properties and the temperature of the food. It has been used to inactivate microorganisms and also extend the shelf life of the seafoods. So that's for the first one. And then for the second one is for the meat and poultry. So electron beam has been applied to meat and poultry industry, which are approved by Food and Drug Administration (FDA) with its own guideline and regulations. FDA approved and irradiation dose for meat products that are sufficient to kill or inactivate the microorganism in red meat and poultry. And then for the third one is electron beam application in biodegradable packaging. As we know, biodegradable packaging decreases the environmental impacts of packaging as they are degraded by microorganisms and mineralized into carbon dioxide and water. The raw material for the biodegradable plastics includes polyacetic acid, which we call PLA, that gives clarity, rigidity, thermal resistance, and strength. The PLA has poor mechanical properties, which we are improved thoroughly by electron beam processing. And then lastly, for the fourth one is the package sterilization. Electron beam sterilization of packaging material is a proven technology that outperforms any legislative and customer requirements. Studies have shown that depending on the level of microorganism, it was found to be effective against yeast, mold, and spores, and no visible microorganism was found after the treatment. However, appropriate packaging material has to be selected to withstand the electron beam radiation. Otherwise, it will not perform optimally as it should be. The combination of electron beam surface decontamination and aseptic packaging reduces the need to sterilize the finished products. So that's all you need to know about the electron beam technology. If you need better understanding, just rewatch our video. Bye.